All right, today we are diving into something, well, kind of a quiet revolution that completely swept through the world of AI. It's the story of this one single protocol that promised to, unify everything. But what happens when a technology becomes maybe a little too successful, a little too fast? Yeah, that's where our story really kicks off.
And really, that's the heart of it, isn't it? We're talking about a technology that was so successful it basically became the industry standard overnight. But, and there's always a but, that very success also unleashed this flood of really complex, totally unintended consequences. So let's back up and start right at the beginning.
Okay, so at the center of this whole thing is something called the Model Context Protocol, or MCP for short. It was released back in late 2024, and its goal was actually super simple: create one standard common language so that AI models could talk to all the software we use every single day. You can pretty much think of it as like a universal translator for all of your AI tools.
So what does that actually mean in practice? Well, AI researcher Sebastian Walcoder explains it perfectly. See, before MCP, if you wanted your AI agent to connect to, say, Google Docs, that was a whole custom job. And what about connecting to GitHub? Yep, another totally separate custom job. MCP's big promise was to create just one simple plug that would work for, well, everything.
And wow, did this simple idea just absolutely explode. I mean, this timeline really shows you just how fast it all happened. It was released in October 2024, and it only took a few months, literally a few months, to become the undisputed industry standard. This was a classic network effect playing out in real time, Once a couple of key tools adopted it, every AI model had to support it. And then, once all the AI models supported it, every new tool had to as well. It just created this unstoppable cycle that locked in its dominance.
But here's the thing, right? When you move that fast, you're bound to miss a few things. And this is exactly where our story takes a pretty sharp turn. That incredible, lightning-fast success, it also created a whole new category of problems. And it all started with a massive, glaring security blind spot.
So get this. The very first version of MCP had a pretty shocking oversight. It had zero authentication. I mean, absolutely none. That meant literally anyone could call and command any tool. And okay, you think just fix it, but fixing it created this logistical nightmare, this three-party problem. Think about it. It's not just you talking to a service like GitHub. It's you telling a totally separate AI to then go talk to GitHub. So who's supposed to be proving their identity to whom? It gets complicated fast.
The best way to understand this security risk is actually by looking at a much older problem. For decades, developers have been fighting something called SQL injection. That's where attackers sneak malicious code into what's supposed to be just simple data. The solution? Build a really strong wall separating the code from the data. Well, now we have prompt injection, and it is the exact same idea, just for AI. You've got malicious instructions hidden inside what looks like perfectly normal text designed to trick the model.
And here's the really scary part. While we now have pretty reliable ways to stop SQL injection, Walcutter warns that for prompt injection, there's just no foolproof way to stop it right now. The very nature of human language, how messy and nuanced it is, makes it incredibly difficult to build that perfect wall separating instructions from data. So, okay, security is a huge headache, for sure. But it's not the only unintended consequence we're dealing with here. The second big problem is something we can call the tool overload trap. And what's so fascinating, what's so ironic about this one, is that the problem comes directly from MCP being, well, too easy to use.
Yeah, it turns out there's a real practical limit to how many tools an AI can effectively juggle at once. And that magic number? It seems to be right around 30. Once you give an AI more tools than that to pick from, its performance, its accuracy, it just starts to tank. The model, well, it simply gets confused.
So why does that happen? Well, it all comes down to the AI's context window. The easiest way to think about it is like the AI's short-term memory, or its disk space. Everything the AI needs to think about for your request has to fit on that disk. But here's the catch. Every single tool you add comes with a long definition, a user manual basically, and that manual takes up space on the disk. So as you keep piling on more and more tools, their definitions start to take up a massive chunk of that memory, leaving less and less room for your actual prompt and, the documents it needs to actually do the job.
To really get a sense of the scale here, Walcutter has this amazing analogy. I like to call it the Jane Austen metric.
A big context window today, say 200,000 tokens, is roughly the length of the entire novel Pride and Prejudice. Now just imagine trying to read that story, but the first half of the book is just a dense, boring, technical manual explaining all the tools the characters might use. There's not a whole lot of room left for the actual plot, is there? That's what's happening to the AI.
So all of these technical limitations, right? The security risks, the tool overload, they force us to step back and ask a much bigger, much more strategic question. Just because an AI can do something, does that really mean it should? And this is what leads us to the search for what people are calling stable AI use cases.
And Woolcoder has this brilliant analogy from his robotics research to explain what he means. On one side, you have an unstable equilibrium. Picture a complex, fancy humanoid robot. It looks incredibly impressive, right? But the slightest little nudge can send the whole thing toppling over. But on the other side, you have a stable equilibrium. This is your simple little wheeled robot. It's not flashy at all, but it's robust, it's cheap, and it gets the job done reliably every single time.
So this brings up a really direct question for anyone building with this technology, or even just thinking about using it. Is the AI solution you're dreaming up an unstable equilibrium? Is it one of those complex, expensive, and frankly, sometimes unreliable systems built to solve a problem that maybe a simpler, more robust solution could handle way better?
Let me give you a perfect real-world example of this. Woolcoder mentioned seeing a team that built this super sophisticated AI agent just to identify what they called flaky software tests. And his question was just so simple. Why not just run the test 10 times? I mean, if it passes some of the time and fails others, well, then it's flaky. That's a simple, cheap, and 100% reliable solution that requires no AI whatsoever.
And you know, this whole strategic question leads us right into our final topic, the very real, very tangible impact of AI on jobs. The debate we always hear is framed as this simple choice, right? Will AI augment us or will it replace us? But the reality, as we're about to see, is way more nuanced than that.
So the key here is to break down work into two totally different categories. First, you've got what we can call expandable work. Think software engineering. If you use AI to make an engineer more efficient, they don't just run out of things to do, right? No, they now have more time to innovate, to create brand new work. But then you have fixed work, like customer support.
See, in these fixed work roles, the amount of work you have is limited by outside factors, like how many customer support calls you get in a day. And here, well, the math becomes brutally simple. As Woolcoder puts it, when an AI can handle that workload more efficiently, you suddenly have work for one person when you had work for 4 people before. It's as simple as that.
And all of this brings us right back to what might be the most important question of all. The MCP revolution, for all its problems, gave us these incredibly powerful new tools. But tools don't come with instructions on how to be wise. And as we weave AI more and more deeply into our world, this is the one question we just have to keep asking ourselves. Just because we can build something with AI, does that mean we should?